Littleton Coin Company is ringing in the holiday season with daily deals. Visit littletoncoin.com for at least 15% off select products now through November 28th. Save on your favorite coins, such as Morgan Silver Dollars, Kennedy Half Dollars, commemorative quarters, and much more. But hurry, each day offers a new deal you don't want to miss. Visit us now at littletoncoin.com. That's littletoncoin.com. Littleton Coin Company, serving collectors since 1945.
The holiday season is here. Visit your local Pep Boys today for 25% off any oil change service. Make an appointment at petboys.com. Offer valid with coupon through November 30th. Additional fees and restrictions may apply. Visit petboys.com for coupon.
This is SpaceTime, Series 24, Episode 124, for broadcast on the 1st of November 2021. Coming up on SpaceTime, astronomers see a white dwarf literally switch itself on and off. A new study looks at the deep roots of Australian geology. And Blue Origin announces plans for a private space station. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have for the first time seen a white dwarf appear to abruptly switch itself off and then on again. The unique phenomenon, reported in the journal Nature Astronomy, happened as the white dwarf was accreting material off a companion star in the TW Pictoris binary system located some 1400 light-years away. White dwarfs are the exposed cores of sun-like stars at the end of their lives. Stars shine by fusing hydrogen into helium in their core. When they run out of core hydrogen, they contract, eventually increasing core temperatures and pressures enough until they begin fusing helium in their core into carbon and oxygen. At the same time, a shell of hydrogen begins burning outside the core. Now, all this causes the star's outer gaseous envelope to expand, and as it's now further away from the contracted core, it cools down, turning the star into a bloated red giant. When our Sun reaches this stage of its life in around 7 billion years from now, its surface will have expanded out far enough to engulf Mercury, Venus, and most likely the Earth as well. Eventually, the doomed star will run out of core helium to fuse, and as it's not massive enough to fuse heavier elements, the star dies. Its outer envelope floats away as a spectacular cloud called a planetary nebula, and its white-hot stellar core is exposed as a white dwarf. Astronomers think about 97% of all stars end up becoming white dwarfs. However, if the white dwarf's in a close binary orbit with a companion star, the intense gravitational pull of the white dwarf can drag or accrete material off that companion. And if it pulls off too much material, passing a threshold of around 1.4 times the mass of the Sun, the white dwarf becomes unstable, triggering a thermonuclear or Type 1a supernova explosion. The white dwarf observed in the TW Pictoris binary system is also accreting or feeding from an orbiting companion star. As the white dwarf feeds or accretes, it becomes brighter. Using NASA's Transiting Exoplanet Survey satellite TESS, astronomers saw the white dwarf lose brightness in just 30 minutes. That's a process previously seen in accreting white dwarfs over a period of several days to months. Now, the brightness of the accreting white dwarf is affected by the amount of surrounding material it feeds on. And this suggests that something suddenly began interfering with its food supply. And because the flow of material on the white dwarf's accretion disk from its companion star is relatively constant, it shouldn't drastically affect its luminosity on such short timescales. Instead, what researchers believe they could be seeing is some sort of reconfiguration of the white dwarf's surface magnetic field. During its so-called on mode, when the brightness is high, the white dwarf feeds off its accretion disk as it normally would. Suddenly and abruptly, the system turns off and its brightness plummets. The authors say that when this happens, it's likely the magnetic field is spinning so rapidly that a centrifugal barrier is physically stopping fuel from the accretion disk constantly falling onto the white dwarf. During this phase, the amount of fuel the white dwarf is able to feed on is being regulated through a process called magnetic gating. In this case, the spinning magnetic field of the white dwarf regulates the fuel passing through the gate on the accretion disk, leading to the semi-regular small increases and decreases in brightness being seen by astronomers. After some time, the system sporadically turns on again, and the brightness increases back to its original level. This discovery will help astronomers learn more about the physics behind accretion, where objects like black holes, white dwarfs, and neutron stars feed on surrounding material from neighbouring stars. This is SpaceTime. Still to come, a new study looks deep into the roots of Australian geology, and Blue Origin announces plans for a private space station. All that and more still to come on SpaceTime.
Tis the season to change your tires at Pep Boys. When it comes to holiday travel prep, your local Pep Boys has you covered. Buy 3 select tires and get the 4th one free instantly. Pep Boys offers online booking, text alerts to track your service, and mobile payments to pay on the go to get you back on the road safely. Make an appointment at petboys.com and don't miss out on these incredible deals. Offer valid through November 30th. Requires installation and additional fees. See store for details or visit petboys.com to learn more.
A new study has shown for the first time that the Australian landmass is made up of different building blocks which fused together more than 1.3 billion years ago. The new data provides the most detailed analysis of its kind yet undertaken. The findings, reported in the Journal of Communication, Earth and Environment, show how Australia's rich geological history is reflected deep below the Earth's surface. The study's lead author, Caroline Aiken from the Australian National University, says Australia's different building blocks are reflected on the planet's surface, but it's been unclear as to what depth these geological differences will be reflected below the Earth's crust. The authors used observations of scattered seismic surface waves known as quasi-love waves, which are created by distant earthquakes, in order to study the Australian geological makeup. Aiken and colleagues used data from more than 2,000 earthquake recordings made by seismometers across the Australian continent. These quasi-love waves showed boundaries deep within and surrounding the Australian continent that correspond to the same tectonic boundaries seen on the surface. Aiken says this suggests that these kinds of geological features are preserved for billions of years. She says the new data about what's happening between 100 and 200 kilometres below the planet's surface indicates the deeper part of the ancient continent is just as geologically diverse as the crust.
So we know that Australia is an old, stable continent, and it has a really rich geological history. And we can see this clearly in the signature of Australia's crust, the different crustal blocks that have different geophysical signatures, like the magnetics and the gravity, for example. But it's been really hard to sort of see that same heterogeneity deeper beneath the surface. So the deeper you go, the harder it is to resolve such features. So the work that I've done is looking at using a certain kind of seismic wave and how it interacts and scatters at such boundaries. And using this sort of unusual technique, I've been able to see that such features extend deeper into the Earth, so potentially between 100 and 200 kilometers depth, which is much deeper than we would typically envision or have resolved these features before. So it's suggesting that the geological diversity of the crust, of Australia's crust, is actually that signature extends deeper into the continent, deeper than we really thought before, I guess, or kind of seen before.
So this is telling us how deep that continental crust is going into the mantle.
Not quite. So we have several layers in the Earth. So the crust is, the rocks we have at the surface, and in Australia that's sort of between 30 and 50 kilometers thick. Then beneath that we have a part of the mantle called the lithosphere, and this is the cold, strong outer layer of the Earth. So that's kind of like the tectonic plate is the lithosphere. And then you have the mantle below, which is a viscous solid, but it can flow. So the signatures that I'm seeing, they're in this lithosphere, they're in the Australian tectonic plate, but they're below the crust. So they're in the mantle, but they're in a part of the deeper part of the continent that sits below the crust, but it's thought to be a sort of strong, rigid part, a really old and cold part of the continent below the crust that we wouldn't necessarily have been able to see before, that this part of the continent also has sort of the geology is expressed within this part of the lithosphere, within this deeper part of the continent. Think of geology as just being in the crust.
These quasi-love waves have allowed you to see into the lithosphere. How are these waves different from the S&P waves that I would have learned about at high school?
When an earthquake happens, it produces two groups of waves. It produces body waves, like the P and S that you mentioned, that travel through the Earth's interior, and it produces surface waves, which travel along the Earth's surface. And we have two types of surface waves, love waves and Rayleigh waves, which are two different kinds of motion. And these quasi-love waves is essentially a love wave that travels along the Earth's surface and a few hundred kilometers below, and it's interacted with one of these boundaries, and part of its energy has then been converted into Rayleigh waves, into a different kind of motion. And that's what I've detected. It's sort of a conversion of this wave energy from one type into another.
Has this sort of study been done elsewhere, or is what you're doing the first time?
It's the first time to do this anywhere in the Australian plate. Such studies have been conducted in some other tectonic settings, so the eastern North America, in Tibet, subduction zones, such as in Italy and the Mediterranean, but it's never been applied before in such a way to the Australian plate or to a stable continent like this, to really try to look at how deep the geology goes.
When you look at the lithosphere beneath the Australian continent, what are you actually looking for? Different densities in different areas?
No, I'm actually looking at, so it's something called seismic anisotropy, and essentially, so that's a technical term, but that word anisotropy means directional dependence of seismic properties. And specifically, it's actually telling me about the pattern of deformation within the lithosphere. And it's actually telling me about different blocks or pieces of the lithosphere, which have experienced different sort of times and styles of patterns of deformation at different times. So as the continent was being built, so all these different pieces being sort of fused together to form the Australian continent, you can imagine, fusing and colliding pieces of continents together is a very big event, causes a lot of deformation. You have mountain buildings, things like we see today, India colliding into Eurasia and forming the Himalayas, right? Events like this really deform the crust and also the lithosphere. And that's what I'm actually picking up in terms of physical properties.
Yeah, but things like the Australian separation from Antarctica, India and Madagascar, that happened much later than the 1.3 billion years. So you're looking far earlier than that.
Yeah, so the Australian continent has a really rich geological history, right? So Western Australia is older than Eastern Australia.
Oh, wow. I didn't know that. That's interesting.
Yeah. Sort of Western and Central Australia. So I don't know if you've heard like the Yilgarn, Creighton, Pilbara in Western Australia. They're some of the oldest parts of the country in the crust. And sort of the western 2/3 of Australia was pretty much formed by about 1.3 billion years ago. And then the eastern part of Australia was much more recent. It was several hundred million years ago that was kind of accreted onto the eastern side of Australia. So really I'm kind of studying, there's all these different processes that happened in time to sort of build up Australia, and many of those were, as I say, over 1 billion years ago. And I've seen signatures that quite possibly relate back to that time.
Does this mean you'd expect to find the same signatures below Antarctica and Madagascar or India?
Yeah, I mean, I think in other parts of the world, I would expect to see similar things. But I don't know yet. So it's kind of the future to try and see, sort of try this technique in other parts of the world to see if similar signatures can be seen. The good thing about Australia is the fact that we're in the middle of a tectonic plate. So there's no plate boundaries within Australia today, which would sort of overprint this signal. So I'm able to sort of use this to sort of see the record of deformation and look at the last major deformational event, which in the case of Australia, in some parts of it was, as I say, over 1 billion years ago. In Australia, we have sort of 3 major cratonic areas. So a craton is the old stable building blocks of a continent. So the oldest parts have been around the longest, and they don't tend to, they're very strong, and it's hard to deform them. And basically these pieces kind of get, over the Earth's history of kind of being shuffled around and sort of fused together to form continents. So in Australia, we have 3. We have the Western Australian craton, which is the sort of the Yilgarn and Pilbara that I mentioned previously. We have the southern Australian craton, which includes the Gawler craton in South Australia. And then we have the northern Australian craton, which is kind of several different fragments that fuse together. And the western Australian craton, that's the oldest. So some of the oldest rocks and minerals come from Western Australia that we have on Earth. And that was, I can't remember the exact date, but that was we're talking about several billion years ago. And then later...
4 point something billion. We're going, 4.2, 4.3, something like that. I think you've got to go to Hudson Bay or parts of South Africa to find stuff as old and possibly even a little bit older.
Yeah, exactly. There's the famous the Jackson Hole Zircon. So some of the oldest crystal fragments on Earth, very soon after the Earth formed. We knew that the continent was this deep that probably goes even deeper. In fact, it could be 200, 300 kilometers deep. But what we didn't know was that the geological characteristics of the crust would also extend that deep. The images we've kind of been able to create before from geophysics, from seismology, kind of just see the deeper part of the continent is just kind of being, kind of cold and kind of uniform, kind of all the same. It's been really hard to see whether the geological events that happened in the past, like mountain building and past plate boundaries, that they actually also deformed this deeper part of the continent and that it would be preserved for this long in time. We've kind of only ever been able to see that in the crust before. Another result from the study was actually that there's some interesting features beneath the continental margins around Australia, places like Eastern Australia and Southern Australia, and I also saw on the sort of western side of Zealandia as well, as we kind of think, there's no plate boundary along those regions. We kind of think of them as being kind of stable and boring. But I was also picking up these signatures here, and those most likely relate to flow in the mantle. I'm suggesting that there's actually something going on beneath there in the mantle below in terms of the patterns of flow. So I'm actually really quite interested in that, to study a bit more about what's happening there. And it suggests that there's some kind of dynamics happening at these margins.
What, between Australia and Zealandia?
Yeah, on the edges of the continent.
Yeah.
Yeah. So it's kind of connected to the transition going from like continental crust to oceanic crust. There's kind of something happening in the mantle below that in terms of the...
Well, New Zealand's been trying to get away from Australia for years.
Yeah, I did try, it was like 50 to 80 million years ago, it was drifting apart there, but then it stopped.
That's Dr. Caroline Aiken from the Australian National University. And this is SpaceTime. Still to come, Blue Origin announces plans for a private space station. And later in the science report, a new study shows that Arctic summer sea ice is now less than half of what it was in the 1980s. All that and more still to come on SpaceTime. Amazon founder Jeff Bezos' company Blue Origin has announced plans to build a privately owned and operated space station in low Earth orbit over the next few years. The venture, called Orbital Reef, will house up to 10 people at a time. The facility will fly at an altitude of around 500 kilometres, with modules providing 830 cubic metres of habitable environment. Orbital Reef, which will support microgravity research and manufacturing, will be a joint venture between Blue Origin and Sierra Space, and it has the support of Boeing and the Arizona State University. Construction's expected to begin in the second half of this decade. The private space station's futuristic modules will feature huge panoramic windows, allowing its inhabitants to enjoy 32 sunrises and sunsets every day. Blue Origin's currently only able to fly to suborbital space with its New Shepard rocket, which is designed for space tourism. However, it is working on a far larger heavy lift orbital launch vehicle called New Glenn. New Glenn will be a rival for NASA's SLS and SpaceX's Starship. The Orbital Reef project's one of several privately funded space stations currently in the planning stages for launch in coming years. NASA already has a contract with a company called Axiom, allowing that company to dock its modules to the International Space Station in coming years as the first stage of plans to eventually develop its own Axiom space station. And just last week, Lockheed Martin, Voyager Space and NanoRacks announced plans for their own space station to be known as Starlab, which could be operational by 2027. It's worth noting the first modules of the International Space Station were launched way back in 1998, and NASA plans to keep the orbital outpost in operation until at least 2028, possibly 2030. This is SpaceTime.
Wells Fargo presents one of the surest ways to grow your money. A Wells Fargo CD account, where you can earn a 5.00% annual percentage yield on an 11-month term with a minimum opening deposit of $5,000. Visit a Wells Fargo branch or wellsfargo.com/CD rates to open a CD account and start growing your savings with us.
Wells Fargo Bank, N.A., member FDIC.
Hello, saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.
And time now to take a brief look at some of the other stories making news in science this week with a science report. A new study has shown that people on the autism spectrum are far more likely to self-harm than the general population. The findings, reported in the Journal of the American Medical Association, show the risk doesn't just affect kids but autistic adults as well. The authors based their findings on 31 individual studies looking at the association between autism and self-harm. There was an almost equal split between studies of children and those of adults. On balance, researchers say the odds of self-harming for a person on the autism spectrum is 3 times that of the general population, with similar high odds for suicidal thoughts and attempts at suicide. A new study shows the worsening global warming situation means summer sea ice coverage in the Arctic now consistently spans less than half the area it did back in the 1980s. The study, reported in the journal Earth's Future, focused on a 1 million square kilometre region north of Greenland and the Canadian archipelago, where year-round sea ice had traditionally been the thickest and most resilient. Scientists found that if emissions continue on their current path, summer sea ice would disappear altogether by 2100, along with creatures such as seals and polar bears. But even under the most optimistic scenario, summer sea ice will dramatically thin by 2050. Fossil footprints found 50 years ago in an Australian coal mine, which had long been assumed to belong to a large raptor-like predatory theropod dinosaur, have instead turned out to be those of a plant-eater. A report in the journal Historical Biology claims the 220-million-year-old imprints come from a proceropod rather than a 2-metre-tall carnivore. Paleontologists say the long-necked Triassic herbivore grew to lengths of at least 6 metres, with legs around 1.4 metres tall. Universities are meant to be places of learning and an open exchange of information. But just like the growing number of once reputable media outlets who have descended into the world of fake news in order to push a particular political agenda, many once learned universities are now offering courses in fake science and useless degrees to go along with them. Tim Mendham from Australian Skeptic says, a case in point is the Indira Gandhi National Open University, which has launched a master's degree course in the pseudoscience of astrology, not astronomy, astrology.
This is the Indira Gandhi National Open University, and they're offering a 2-year course in astrology, a master's course. So therefore, it will provide students with the practical life of human beings under Indian Oriental science, from time knowledge, planetary motion, solar eclipse, lunar eclipse, to the happenings in space based on the opinions of Indian sages. Basically, it is pure astrology. Astrology and a lot of superstitious beliefs are fairly common in India. And, you know, if you look at certain papers I've looked at, actually newspapers and things, they have the Lonely Hearts column, or actually the Looking for a Partner column. Parents put an ad in for their daughter and saying, we're looking for a person with these qualifications, and please send your astrological chart. So they're choosing partners for their kids based on the horoscope. So naturally enough, adding this sort of master's course in a university which does teach science and teaches, all sorts of proper scientifically based courses, etc., to offer astrology has upset a lot of them.
Yeah, that's the thing. When I first saw this story, I thought, this is a Skeptic's course on astrology, how to show it's a load of garbage. But no, this assumes that it's real.
But the thing is, the Skeptics have always promoted the idea. By all means, study these things. Study parapsychology, study psychic power, study astrology, but look at it from an academic, if you like, a proper critical thinking point of view. To look at how it's practiced, not teach it as a job. And that's what is happening, has happened in a lot of courses in Australia. Energy healing was being taught at one stage. Pet chiropractic was being taught at one stage. There's obviously several universities teaching chiropractic in about 5 universities, I think, in Australia, as a job. Not as let's look at chiropractic, see if it works, etc.
Well, we even have situations here where universities were teaching Chinese medicine. They've stopped now, but not without some protest by one of the professors.
Yeah, that's right. I mean, I think that was at UTS in Sydney, University of Technology in Sydney. There's an organisation within the University of Western Sydney which does research in TCM, traditional Chinese medicine, and they would say it's doing scientific research on the validity of it, but we have our serious doubts about that, especially as it's sponsored by supplements people. If they're spending money on real research, that's a good thing, but if they're spending money to get their name out there, that's a different issue. But we did a big study a number of years ago. We looked at every university in Australia, and there was only one university we could find that wasn't teaching some form of woo, as we call it, sort of pseudoscience, pseudo-medicine, and teaching it not necessarily as a study, which as we say is okay, but teaching it as a practical, almost like a TAFE course, teaching it how to be a chiropractor, how to be a naturopath, how to be whatever, how to cure people with energy therapies and that sort of stuff. Some very, very strange things that were going on in universities. We complained to all the universities and said, you realise you're doing this. Half the time they didn't know. The Vice-Chancellor's office didn't know. Some of them got back to us and said, mind your own business.
Yeah, because they do know. They're just doing it because this is another income revenue stream. That's all. That's what Absolutely. It's all about. They're just prostituting themselves and their universities' names.
Yeah, absolutely. You said it. That's what it is. It's money making because there's a market for it.
That's Tim Mindham from Australian Skeptics. That's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.
Hello, Saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.
Hello, Saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.